Hey, what's up, guys? Welcome back, man. Second semester, second goddamn semester is on its way. Man, let's make it better than it was last semester. Let's get through it and let's get started. All right, man, we got 9-1 right here, which is day one, solving radical equations. So the essential question, how do you find the solutions to a radical equation? All right, well, listen, man, step one, all right, and yo, listen, use the steps, people. So step one, man, isolate the radical. All right, isolate the radical. Then after you isolate the radical, you want to raise both sides of the equation to the power equal to the index of the radical. Now, you talk about the index, man, you got to remember what the index is. All right, the index is when you have a radical. Hold on. When you have a radical, all right, the number right here, all right, like, you know, square root, there's nothing there. It's an implied 2, all right. But when you have like a 3, that's the cube root. The index is 3, all right. When you have a fourth root, all right, the index is 4, all right. But anyway, though, man, back to what I was saying. It says raise both sides of the equation to the index, or to the equation to the power equal to the index. So let's say on this side right here, you saw this is the cube root. The cube root of x equals 2. So to get rid of this cube root, I want to cube it. All right, so I can negate that side, and I also want to cube this side. Remember, what you do on one side of the equation, you do to the other. So now I have x equals 8. All right, like that. All right, and then it says simplify and solve. So that's what we did. X equals 8. Solve that. 2 to u is 8. All right. So now, man, let's go ahead and do an example, man. All right, right here. First, what we're going to do is see the radical. All right, this whole portion of the equation is in this radical jail right here. All right, it's underneath the radical. So we're going to solve what's outside. All right, so we're going to divide by 3 on both sides. So I have x minus 5, square root of x minus 5 equals 6. And then remember the index right here is 2. All right, because it's not there, it's implied 2. So that means it's a square root. So we square both sides. All right, so right here, the radical and the exponent negates each other or cancel out. So you have x minus 5, and you have right here 6 squared is 36. All right. So now what we do is we add 5 on both sides. So once you add 5, you get x equals 41. All right. Now check, man. This is the other part, solve and check, where we check it. All right. So when I check it, you have 3 times the square root of 41 minus 5, and that should equal 18. So we have 41 minus 5. That's 36. The square root of 36 is 6. Oops, I'm tripping. That equals 6. And that's 18. All right, so that checks out. That's the same thing. That works out, okay? Let's do one more example. Again, all right. See the radical right here? This is in radical jail. All right, so what we're going to do is divide by 4 first. All right, like that. So divide by 4 on both sides. Then you have the cube root of 2x minus 5 equals 3. And then see how we have the cube root? So we're going to cube both sides. All right, that way the radical and the exponent cancels. All right, and 3 times 3 times 3 is 27. Now we're going to add 5 on both sides. So that gives us 2x equals 32. And then divide by 2 on both sides, and x equals 16. All right. So then we go through and we check it. Let's check it. All right. We're going to take 16, plug it in. 4 times the cube root of 2 times 16 minus 5. And that should equal 12. So 2 times 16 is 32. And then right here, we have 32 minus 5. That's going to be 27. The cube root of 27 is 3. And 4 times 3 is 12. So there we go. That checks out. All right, that checks out right there, okay? Now, we have the U tries. All right, oops, didn't mean to do that. All right, we have the U tries. I'm gonna go ahead and work through them. So let's see here. Let's see. First, I would go ahead and subtract the 3 because you see this radical right here is all in the radical jail. So I would subtract 3 on both sides. All right, like that. Okay. So minus 3. So we have the square root of 4x minus 8 equals 6. Then to get rid of, remember the index here is 2. So to get rid of the square root, we're going to square both sides. So the radical and the 2 would cancel. So I'm left with 4x minus 8 on the left. And on the right, we have 36. Now I'm going to add 8 to both sides. So we have 4x equals 44. And finally, we're going to divide by 4. And we get x equals 11. All right, x is 11. So now we got to check it, okay? You have to check it. Make sure you check it. I will check it. All right, I take that 11. I plug it in. So you have 3 plus square root of 4 times 11 minus 8 equals 9, okay? And then when we get, we go 4 times 11 is 44. So 44 minus 8 is 36. And then we have the square root of 36 is going to be 6. Oops. And then 3 plus 6 is 9. All right. Boom. All right, that checks out, okay? Now, we'll do this last one right here. So we got the cube here. Let's cube both sides, right? The cube and the cube roots going to negate each other. So you have 3x plus 1, all right, equals 64, because 4 times 4 is 16, times 4 is going to be 64, okay? So now we're going to subtract 1. All right, subtract 1, and we're going to get 3x equals 63, and then divide by 3, and x will be 21. All right, now I'm about to goddamn check it one more time. All right, we have 3 times 21 plus 1 equals 4. All right, so now we got 3 times 21. All right, that's 24. All right, so we have the cube root of, 3 times 21. I did 3 plus 21. I don't know what I was thinking. That's 63. All right, so 63 plus 1 is going to be 64. And then you have the cube root of 64, all right, is 4, which equals 4. So, boom, there we go. All right, that checks out, all right? That checks out, okay? So now what we got to do is, all right, so there we go, man. Make sure you check them. All right, check behind yourself. So now let's move on over here. Example B, all right, equations containing 2 variables. All right, 2 variables. And man, yo, you got to just work it out, guys. It's the same logic. All right, and if you look at that left side, see how that whole left side is covered with the goddamn radical? The whole thing has a radical. So what we're gonna do is I'm going to square this whole side. All right, there's nothing in front to move, so I'm going to square this whole side. I'm also going to square this whole side. All right, and the reason I do that is because I want to get rid of this square right here. All right, I'm also get rid of that one because that's a square root too. All right, get rid of the square root, get rid of the square root. So here's what I do. I have 8x plus 6 because that square root and that square negated each other. And over here, when you square this whole right side, you got 3 squared is 9. And the square root of x squared is going to be just x because that square root and that square negate each other. So it's just x. Now I just solve it. I'm going to go minus 8x on both sides because I'm going to combine like terms. And that's going to give me a single x. And on the left here, I just bring down my 6. So 6 equals x. All right. Now, again, you want to check yourself, okay? Check. All right. So when you check it, you're going to go look at the original equation. X is 6, so we have 8 times 6 plus 6 equals 3 times the square root of 6. All right. So now what we have is 8 times 6. All right. That's going to be 48. All right, so you have the square root of 48 plus 6, and you have 3 times the square root of 6 on the right. Now, 48 plus 6 is going to be 54. The square root of 54, all right, which equals 3 times the square root of 6. Now, we got to go way back to the beginning of the year when we were doing radicals. All right, remember, we can factor this, all right, and one of the factors of 54, all right, is going to be 9, and the other factor is going to be 6. I want you to notice that one of the factors I factored, I divided this 54 is a perfect square. This is a perfect square. I can solve this. Hold on, let me do this. All right, the square root of 9 is 3. The square root of 6 is the square root of 6. It's not a perfect square, and that does equal 3 times the square root of 6. All right, so that checks out. Okay, check yourself. Okay. All right, here we go. All right, so let's look at the you try. All right. Again, this whole left side is cubic. All right, so again, you do this when one whole side, man, is under a radical. That's why I do this. All right, I want to get rid of this cube root, so I'm going to cube both sides, okay? Cube both sides. All right, cube both sides. So the cube and the cube root would negate each other. And over here, you got to do the whole right side, okay? So that 2 is cubed, so that's 8. 2 times 2 times 2 is 8. And then right here, you have times x minus 1, because that is going to negate with that, all right? So now you have x plus 6 equals, distribute your 8. All right, and then I'm going to combine like terms, so minus x. So that's 7x. And then you have 6 equals 7x minus 8. And then I'm going to add 8 on both sides. So I have 14 equals 7x. Divided by 7. And x equals 2. All right, x is 2. All right, real quick, I'm just going to check it. All right, 2 plus 6 equals 2 times the cube root of 2 minus 1. All right, so right here you got 2 minus 1. That's going to be 1. So you have 2 times the cube root of 1. And 2 plus 6. 2 plus 6 is going to be 8, man. I'm trying to blank, okay? So now, the cube root of 8 is 2. And right here, the cube root of 1 is 1. So you have 2 times 1, which is 2. All right, so this checks out, okay? This checks out. All right. Lastly, man, this last part, it says try solving by graphing. All right, graph one side of the equation, all right, as y1, and the other side is y2. All right, use the second calc 5 feature to find the points where the function intercepts. All right, this method will not result in extraneous cases. All right, this will not result in extraneous solutions. All right, so here's what I mean. Let me set up. Give me a second. All right, so again, man, what you do is you put 1 in the y1 column, one side of the equation, And then you put the other side of the equation in y2. All right, like so. Now, what you do is you're going to make sure that your window and everything is right. Make sure one is on in y1, the other one's in y2. Then you hit graph. All right. Now, when you hit graph, it's going to intersect. All right, and everywhere it intersects, it is an actual point. All right, it is an actual solution. All right, if you look, this intercepts right here at 1. All right, right there, it intercepts at 1. If you also don't see it, you can consult your graph, your table. All right. You can consult your table like this. All right, and you see it right there at 1, 4. I see the 1, 4 for y1 and 1, 4 for y2. They intersect right there. All right. So see how they're the same? That's how you know which value it is. Okay. All right. Now back to. So we saw the answer. The solution was 4. Okay. Or the solution was 1. X was 1. All right, we saw that X was 1, so I'm going to write it down right here. All right, X was 1. We saw that X was 1. So now what I want to do is show you algebraically, you know what I'm saying? Show the work to show you. All right, so you can just see what I mean by this method will not result in extraneous cases. So if you look this left side, this whole thing is under radical, so I'm going to square this whole side to get rid of the radical, which means I want to square this whole side. All right, so what I get is those are going to cancel out. So I have 2x plus 14. And over here, I have x plus 3 squared, which is x plus 3 times x plus 3. All right. So now 2x plus 14 equals, you got a FOIL right here, FOIL. So you have x squared plus 3 times 3. 3 plus 3 is 6x, and 3 times 3 is 9. All right. Now I'm going to subtract 2x over here. So minus 2x. All right. And then we're going to subtract 14 on both sides. So we end up with 0 equals x squared plus 4x minus 5. All right. Now, with this, I'm going to factor it, okay? I'm going to factor it. So when I factor this, I'm going to get 0 equals x plus 5 and x minus 1. All right. Now, I set each one of those equal to 0 and solve. And solve. All right, x equals 1. So there we go. I got my 2 solutions. But one of these, as we saw, is an extraneous case. All right, here's what I mean. If I take these x values and plug them in, I'm going to do the negative 5 just so you can see. 2 times negative 5 plus 14 is supposed to equal negative 5 plus 3. So you have 2 times negative 5, that's negative 10 plus 14. And negative 5 plus 3 is going to be a negative 2. All right. Now, right here, negative 10 plus 14 is going to be square root of 4. The square root of 4 is 2. The problem is 2 does not equal negative 2. All right. So this does not check out. Okay. This does not check out. Therefore, this is not an answer that's an extraneous case. All right, but again, my purpose of doing this was to show you that the answer is 1. All right, if you did this algebraically, you would get 2 answers, but this answer right here is not an answer because when you solve it, it gives you solutions that are extraneous, they're not consistent. 2 does not equal negative 2. That's not a true statement, okay? All right, one more real quick. I just want to do it, plug it into the calculator. I don't know if you have a calculator at home, so we do it in class. This problem right here, we'll do it in class. All right, and when you do it, all right, I'm just going to show you anyway, just so you can see. Maybe you're absent. All right, so again, put the left side of the equation in y1, the right side of the equation in y2. All right, then hit graph. All right, so we're going to let it graph. I want to look for the intersections. So right there, we have an intersection right here at 3, right there. There we go. Right there, there's one right there. All right. And then there's an intersection right here. 1, 2, 3, 4. -4. We have it right there. So it's 2 intersections. So therefore, when we go back to our graph, 2 solutions, we get x equals -4, and we get x equals 3. Now I'm just gonna check them real quick just so you can see. All right. So when I go -4, I plug in -4 right here. So -9 times -4 plus 28 equals -4 plus 4. Okay. So we get -4 times -4 is going to be a positive 36. All right. And so we have 36. Well, here, let's do it. 36 plus 28. All right. And over here, you have a negative times a negative. That becomes positive, so 4 plus 4. And then 36 plus 28 is going to be 64. Square root of 64, and 4 plus 4 is 8 on this side. So now the square root of 64 is 8, and 8 equals 8. So that checks out when you evaluate this value. Now when I check this one, 3, you have -9 times 3 plus 27 equals -3 plus 4. So now -9 times 3 is -27. All right, plus 27. Oh, I'm sorry, 28. I wrote 27. 28. There we go, 28. That's 28. So that's -27 plus 28. That's going to be the square root of 1, which is 1. Over here, that's -3 plus 4. Well, that is going to be 1. Therefore, 1 equals 1. That checks out. So these are the 2 solutions, okay? These are the 2 solutions, all right? All right, man. Hey, this video, man, we kept it under 25. Good job to me. Hey, listen, I really want to just encourage you to just have a great semester, all right? We got about 5 more months together. All right, let's enjoy it. Let's make the best of it. Let's do great things. All right, let's come out on top, man. Good luck this semester, and I will catch you later.